Question 23. If the speed of a wave increases to 1.5 times its original speed, while the frequency remains constant, how does the wavelength change? So another ratio question. Here you can see that the speed was increased to 1.5 times its original value. So the new speed is equal to 1.5, the old value. He wants me to see what's the effect of changing the speed on the wavelength while the frequency is kept constant. Again, with a triangle, let's search for an equation that has both the speed as well as the wavelength. V equals to lambda f. So you can see that because he wants me to see what's the effect of changing the speed on the wavelength, how does the wavelength change? He wants me to see what's the effect of changing the speed on the wavelength. I need to put wavelength on one side, everything else on the other. So our old equation is lambda equals to V divided by F. So this is the old equation, equation number 1. Equation number 2 is the new one. The new wavelength is equal to the new speed divided by the frequency. Now you might say, why didn't I say the new frequency? Well, remember, it says the frequency remains the same, remains constant. We didn't change the frequency. We only changed the velocity or the speed. Type. Now we need to substitute the relationship we turned into an equation here from the words, and then we're going to divide the two equations over each other. Okay, so lambda new, the new wavelength, is equal to the new speed is 1.5, the old one. So 1.5, the old one, the old velocity or speed, divided by the frequency. There you go, this is the new equation. And this is the old one. Wow, great. Okay. So third step is that we need to divide these two over each other. The new one over the old one. That's 1.5 V over F. Get bored after. This is like the fourth question on ratios. Over V over F. See? Lambda, V over F. Yeah, okay. You need to cancel a few things here. You can see that V and a V cancel, the F and F cancel. So you have 1.5 over 1 over 1 over 1. 1 over 1 is 1. 1.5 over 1. That's 1.5. Good. So the new lambda over the old lambda is equal to 1.5. Cross multiply. You can see that the new wavelength is equal to 1.5, the old wavelength. So you can see when the velocity increased to 1.5, its original value, the wavelength has increased by the same amount. And it makes quite good sense. Why? Remember that lambda equals to V over F. If we double the speed, the wavelength doubles. If we triple the speed, the wavelength triples, because the relationship between the speed and the wavelength is a direct linear relationship. That means if this one is multiplied by a factor, then this one will be multiplied by the same factor. So this question says that the speed is multiplied by a factor of 1.5, hence the wavelength will be multiplied by the same factor as long as F is kept constant. Right, so this is the first way of finding a ratio. Of course, you know there's another way, which is finding what number entered the equation. So lambda equals to V over F. You can see that the number that entered the equation, let me just choose another color, is 1.5, right? So maybe we can, oopsie, 1 minute, all right. So let me write it as a separate equation so that you don't. All right, so The new wavelength is 1.5 V divided by F, right? Alright, divided by F. Now this right here, this one right here, this is the old lambda. This is the old lambda, this is the old wavelength, see? See, this is the old wavelength. So the new wavelength is equal to 1.5 multiplied by the old wavelength. Another way to find the same answer, see? Great. Okay, okay, okay.